Hi friends, today we are going to discuss about the important topic called syllogism. Syllogism is not only asked in placement exams but also asked in many competitive exams too. The one company which asks syllogism most is Infosys. First of all, what is syllogism? Syllogism is a Greek word which means inference or deduction. The problems based on syllogisms are on two parts. The first part is proposition and the second part is conclusion. The proposition is nothing but a sentence that makes a statement giving relation between two terms. And the conclusion is one thing which we draw from the first proposition or the second proposition or from both the propositions. What we have to do here is we should check whether the conclusion given is true or false based on given propositions. These syllogism sums can be solved in three different methods: logical method, formula method, and the third one is Venn diagram method. Of this, we follow logical method and Venn diagram method for the easiest solving of each problems. However, we have to know the following quantifiers before. The quantifiers are all, no, some not, and only few. All means everything, no means nothing, some means part of a thing that is chosen, some not means part of a thing that is not chosen. Only few means combination of some and some not. There is a difference between some and only few. Some means it tells about a part of a thing that is chosen, but it doesn't tell about the part that is not chosen. Only few is the combination of some and some not. It tells about the part of a thing that is chosen and part of a thing that is not chosen. For example, if I say in a class of students only few are boys, this means that in a class only few are boys and the others are not boys. It is having the meaning of both some are boys and some are not boys. But if I say some are boys means it only say that some are boys and doesn't tell about the other part of the class. Here we learn how to draw Venn diagram for these quantifiers. The first one is all A is B. This is A, and if I say all A is B means you have to represent this in Venn diagram like this: A, B, that all A is within B. The second is no A is B. This is A and this is B. If we draw like this means there is no relation. We have to indicate the relation that no A is B. So we are indicating that no A is B. A is not in condition with B. Then some A is B. This is A and some part of A is B. Then some A is not B. This is A and some part of A is not in condition with B. Only few A is B. This means the combination of some and some not. A, some A is B and some part is not in condition with B. Look into this table. This table shows when the conclusion will be true and when it will be false. For known condition and the conclusion agrees in line with the conclusion will be true. If possibility asked for an unknown condition, the conclusion will be true. Maybe, can be, or the words that also indicate possibility. For a known condition and the conclusion doesn't agree with the condition, the conclusion will be false. For an unknown condition, the conclusion will be false. If possibility asked for a known condition, the conclusion will be false. These are the situations where the conclusion will be true or false. Let me give an example. In a class of 6 students, A, B, C, D, E and F, A, C, E are boys, B, D, F are girls. The statement is given that all boys are handsome and girl D is fair. The first conclusion is, some boys are handsome. Is it true or false? This is true, because if all the boys are handsome, they are selecting some boys and asking that if these boys are handsome or not. Yes, if all the boys are handsome means definitely some boys are handsome. This is true. Girl D is unfair. This is false, because in the statement it is given that girl D is fair. The third conclusion is girl B is fair. Here they have not given any information about girl B. So for an unknown condition we have to write false. Girl F is fair being a possibility. This is true or false? This is true, because they have not given any information about girl F. So if possibility is asked for an unknown condition, this is true. Then the next conclusion is boy A being handsome is a possibility. Boy A is handsome being a possibility. They say the all boys are handsome is given in the statement, but they are asking possibility condition for a known condition. So if they ask possibility condition for a known condition, then this is false. Then the final conclusion is only few boys are handsome. They have given that all boys are handsome, but here in the conclusion they are inferring that only few boys are handsome. This means only some boys are handsome and some boys are not handsome. Is it so? No, that all the boys are handsome. This is not in line with the condition. So this is also false. Here the method we followed for inferring the conclusion is logical method. In the next sum we can infer the conclusion through Venn diagram method. What is the statement given? All men are girls. Some girls are students. How to draw Venn diagram for this? All men are girls. The next statement is some girls are students. Some girls are students. Some may draw the Venn diagram as this. Let this be men and this be girl. For the second statement, some girls are students, they will draw as some girls are students. Is it right or wrong? Wrong, because it is given that all men are girls. Yes, all men are girls. Some girls are students. Some girls are students. But this diagram shows a new statement that some men are students. Yes, there is a relation created between men and students. We should not create any relations that is not given in the statement. We should follow the Venn diagram as per the statement. So this is wrong. We have to follow the Venn diagram like this. Then we see the conclusion. What is the conclusion here? All girls are men. All girls are men. Is this possible? No. All men are girls, but all girls are not men. So this is false. Some girls are not students. Here it is said that some girls are students, but we don't know about the other part of girls. Maybe some girls may be students or may not be. We doesn't know about that. So this is also false. Here we see our next sum. What is the statement given? No toy is a doll. no toy is a doll. Toy is not in condition with doll. All boxes are toys. So we can draw the boxes inside toys. All beers are dolls. So we can draw beer inside dolls. All dolls are baskets. All dolls are baskets. Yes, this Venn diagram is as per the statement. Then the conclusion is all baskets are toys. All baskets are toys. We don't have any relation between baskets and toys. So this is false. No box is a beer. No box is a beer. Is there a relation between box and beer? Yes, because the box is within toy, the beer is within doll. There is a relation between toy and doll. That is, no toy is doll. So no box is beer is true. All boxes may be baskets. Is there any relation between box and baskets? Yes, there is no relation between box and baskets. So if possibility is asked for a unknown relation, this is true. All beers are baskets. All beers are within baskets. This conclusion is true. No doll is a box. No doll is a box. Is it true or false? Yes, the box is within toy. The toy is in not condition with doll. So no doll is a box is also true. Here is our next problem. What is the statement given? All lotus are flowers. This is lotus. All lotus are flowers. Next it is given no lily is a lotus. Lily, no lily is lotus. That is, lily is not in condition with lotus. In the conclusion they have given no lily is flowers. Is there any relation between lily and flowers? No, there is no relation between lily and flowers. So this is false. Some lilies are flowers. Is there any relation between lily and flowers? No, there is no relation between lily and flowers. So this condition is also false. If both the conditions are false, and in the option if it is given either 1 or 2, neither 1 nor 2, what will you opt? Yes, if both the conditions are false, we will opt neither 1 nor 2. But in syllogism, if both the conclusions are false, we have to check for complementary pairs. What is complementary pair? If the given variables in both the conclusions are same and occupies the same positions, and if the words no, some, all, some not, this is the complementary pair. If these pairs are present, then the option is either 1 or 2. Yes, if both the variables are same and occupies the same position, we have to see for the complementary pair. No sum, all sum not. Here the complementary pair no sum is present. So the answer is either 1 or 2. Here see the sum. This is a new pattern of syllogism. What is the new pattern here? They have given the conclusion and we have to find the right statement. In normal syllogism, they will give the statement and we have to infer whether the conclusion given is right or not. This is similar to finding appropriate questioning for an answer. Yes. Let's see the sum. What is the conclusion given? Some tulips are not lily. Some flowers are roses. Yes. What will be of the 4 statements? What will be the apt one for these conclusions which satisfy these conditions? Here the first conclusion is negative and the second conclusion is positive. So the statement will have both the negative and positive statements. See the four statements. Negative is found, positive. Negative is found, positive. Negative, positive, negative, positive. Yes, the four statements contains both the negative and positive statement. So we cannot eliminate to this method. So we have to check for each and every statement. What is given? Some tulips are not lily. You have to see the relation between lily and tulip in the statement. Yes, tulips. All roses are tulips. There is a connection made by roses. Some roses are not lily. Okay, some roses are not lily. All roses are tulips. Then it have the meaning that some tulips are not lily. According to the first statement, the conclusion 1 is true. Then some flowers are roses. All roses are tulips. All tulips are flowers. Then it is giving the meaning that all flowers are roses. That means all roses are also flowers. Yes, all flowers are also roses. Then if all flowers are roses means some flowers are roses is true. So the first statement satisfies both the conclusion 1 and 2. We have to check for the second statement. All tulips are rose. Some lilies are not rose. Some tulips are flower. Yes, all tulips are rose. Some tulips are flower. Then this doesn't satisfy the second conclusion. So this doesn't come. All rose are lily. No lily is tulip. Then this doesn't satisfy the first conclusion because some tulips are not lily. Yes, here they say no lily is tulip. In the fourth statement also the same thing repeat. No lily is tulip. So we can eliminate the C and D option. So statement 1 satisfies both the conclusion. So statement 1 will be the correct option.